Hello everyone. In this video, we're gonna solve a problem that involves the concept of normal stress. In this problem, we have two solid cylindrical rods, rod AB and rod BC, which are welded together at point B. Knowing that the average normal stress in rod AB must not exceed 175 psi, and the average normal stress in rod BC must not exceed 150 psi. In this problem, we need to determine the smallest allowable values for D1 and D2, which are the diameters of rod AB and the diameter of rod BC. So let's get started. In this type of problems, the first thing you need to do is to draw a free body diagram for the whole structure. Since this structure has only one support, which is a fixed support at point A, we will only have the reaction forces at point A. Those reaction forces are A sub y, A sub x, and the bending moment. Since in this case we're interested in finding the axial load, we will sum all the forces along the y direction. Once we sum all the forces, we obtain that A sub y is equal to 70 pounds going up. Now, we are ready to start cutting the member into small sections. This is with the purpose of finding all the different internal loads that this structure has. So, for section AA, we only have the reaction force at point A and the internal force N, which is the normal force, in member AB. If we sum all the forces along the y direction, we can get the value of the normal force along member AB. In this case, the normal force acting on member AB from point A to right before the 40 pounds force is applied at point B. In this section, we can see that the internal normal force of the member AB is 70 pounds. We can move on to analyze the next section, section BB. Once we have all the forces in the free body diagram of the segment, we can start adding all the forces along the y direction so we can find the value of the normal force at that point. So from here, we can see that the normal force has changed, and this is due to the 40 pounds force applied at point B. Now we have almost everything done. Once the internal forces acting along each member are found, we can go ahead and start calculating the normal stress. And from there, we are able to find D1 and D2. If we recall from the last video, we know that the normal stress on a member is equal to the normal force divided by the cross-sectional area. In the case of section AB, we have that the maximum allowable stress for that member is 175 psi. And in the case of member BC, we have that the maximum allowable stress is 150 psi. In this case, we know the normal force and the allowable stress of both members. The only thing we don't know is the cross-sectional area. If we isolate the area, we will be able to solve for D in both cases. We found that the minimum cross-sectional area of rod AB should be 0.4 square inches. whereas the minimum cross-sectional area for member BC has to be 0.2 square inches. From there, we can find the diameter of each section. Since we know we have cylindrical rods, we know that the cross-sectional area we are interested on is the area of a circle. In this case, by definition, the area of a circle is pi over 4 times the diameter squared. And then from there, we are able to find the diameters since we already have found the area. From there, we found that the minimum diameter of rod AB is 0.71 inches and that the minimum diameter for rod BC is 0.50 inches. That will be our final answer. I hope this has helped you understand a little bit more the concept of normal stress. Thank you for watching.